Okay, hello everyone. We are discussing application of Fourier transform. In our last class, we have been discussed where Fourier sine transform is going to be applied. If in your question u x equal to 0 t is given, then Fourier sine transform we have to apply. If in the question your initial value condition will be given del by del x of u 0 t, that means at x equal to 0 t is given, then Fourier cosine transform we have to use. So in our last class, this question we have been discussed in detail, that is your distribution of temperature in a semi-infinite bar. The heat equation is your del u by del t c square del square u by del x square, and here u x0 equal to fx and u 0 t equal to 0. That means x equal to 0, t value 0 given. So we applied Fourier sine transform. Same question we have to consider, but it is given that del u by del x 0 t. Here today we are going to discuss same question, but del by del x of u 0 t equal to 1 value minus lambda 1 constant has been given. So if this initial value will be given in the question, then we have to apply Fourier cosine transform instead of Fourier sine. Okay, so if you are going to compare this question and this question, here you can see that u x0 is given as fx, and in our today question this one u x0 is given as u. Okay, and uxt is bounded. Obviously it will be bounded because the rod or the material whatever we are going to be choose we have been considered, that is a semi-infinite bar. Okay, a semi-infinite bar which is extended from 0 to infinite. Okay, so let's start to solve this question. Okay, solution: the given differential equation, and here you have to remember always that here u means it is the function of xt, and here u is the function of xt. So we have to write the given differential equation, heat equation, the given heat equation, the given heat equation is del by del t of u, which is the function of xt, equal to c square into del square by del x square of u, which is the function of xt. So let this is your equation number 1. Okay, so in the question as it is given this value, we have to apply Fourier cosine transform on this equation number 1. So you have to write apply Fourier cosine transform on equation number 1. You have to check if it is given, then you have to apply Fourier cosine transform. If u 0 t is given, then you have to apply, if u 0 t is given, then you have to apply Fourier sine transform. Okay, so you have to apply that Fourier cosine transform on the left hand side of the equation number 1, del by del t of u xt is equal to, that implies Fourier cosine transform applied over c square into del square by del x square of u, which is the function of xt. Okay, so that implies this will be written as 2 by pi root over into 0 to infinity this function del by del t of u xt cos omega x into dx. Okay, is equal to, here c square is constant taken outside, and Fourier cosine transform on second derivative with respect to x of u x t. Okay. That implies here you can see that the integration with respect to x. So del by del t taken outside, del by del t of 1 by 2, sorry, 2 by pi, 2 by pi root over 0 to infinity u x t into cos omega x dx is equal to c square Fourier cosine transform applied over second derivative with respect to x of u, which is the function of x t. Okay. May you have been remember that suppose we are going to consider a function ft and we are going to apply Fourier cosine transform over that. It will be written as 2 by pi root over 0 to infinity f of t into cos omega t dt, and this is nothing but this will be written as Fourier cosine transform of omega. Okay. Now you just compare this one with respect to this one. Okay. This with respect to this one, 2 by pi root over 2 by pi root over 0 to infinity 0 to infinity. Instead of ft, it is here it is uxt cos omega x dx. That means Fourier transform applied over x variable. Okay, here Fourier transform applied over t variable. So wherever the t, there we have to write omega. So here we have to write what? Capital F instead of x omega, and t is there t. Okay, del by del t is there, del by del t. Okay, so that implies here you have to write that implies del by del t of capital F cosine transform of omega t is equal to c square is there. Fourier cosine transform over second derivative will be written as, first I am going to write, I am going to explain then. Okay, will be minus omega square, this value, Fourier cosine transform of this one, second derivative of u with respect to x, will be minus omega square capital F c omega t minus 2 by pi root over del by del x of u0 t. Okay, why it is and how it is, you just recall that Fourier cosine transform of second derivative of fx, suppose function is your fx, then this value is nothing but minus omega square capital FC omega minus 2 by pi root over del by del x of f of 0. That means instead of x we have to put 0. That means x equal to 0. So here you can see that here Fourier cosine transform of second derivative of u, which is the function of x and t. Okay, so if x and t, so instead of so here Fourier cosine transform is applied over x variable, right? Here instead of x we written omega, right? So hence we have to write minus omega square Fourier cosine transform of omega t, because here Fourier transform will be applied over x variable. So instead of x we have to write omega and t is there. Okay, minus 2 by pi root over here, see here you can see del by del x of f of 0, del by del x of the initial function is u x0. So instead of x we have to write 0 t. Okay. Okay, then that implies we can further we have to simplify this one. Okay, so here uh, you can see that del by del t of Fourier cosine transform of omega t, or we can write capital FC omega t is equal to c square minus omega square capital FC omega t. Here you can see in your question del by del x of u 0 t is given as minus lambda. So instead of del by del x of u 0 to t will be written as minus lambda. So minus lambda, here minus, so plus lambda into 2 by pi root over. Okay. Okay, here you can write also as in question given that del by del x of u0 t equal to minus lambda. Okay, next that implies del by del t of capital FC, which is the function of omega t now, and here you can see this term is minus taken this side, it will be plus c square omega square FC omega t, FC omega t is equal to c square lambda, c square lambda into 2 by pi root over. Okay, so here you can see that this is a first order linear differential equation. So this is a first order linear differential equation. So how we are going to solve it? You just recall that if first order differential equation is in the form like this, then how we solve it? You just recall that suppose first order differential equation, it is given like this: dy by dx plus ey equal to q. So if I am going to compare this first order differential equation with this one, both are alike. You can see del by del x, here del by del t, y instead of y fc omega t is there, plus constant, here constant is your c square omega square, y means fc omega t is equal to another constant. To solve this differential equation, we have to use integrating factor, or the solution of this differential equation. We know that y into exponent of integration p into dx is equal to integration of q into e to the power integration of p dx into dx plus c. The solution of this differential equation is this much, already we know, right? So if I am going to compare this differential equation and this differential equation, both are first order differential equation. So the solution of this differential equation, what we are going to write in this format, we have to write. So we put it as equation number 2. Okay, the solution of equation number 2 will be what we have to write, y. Here y means capital FC omega t into e to the power integration of p dx is there. So p dx means here p is nothing but c square omega square, so this is the derivative with respect to t, this is the derivative with respect to x only for that dx. So here we have to write dt. Okay, will be equal to q into e to the power integration of p dx. So q, here q is nothing but this much, right? This much value. So that we have to write c square integration, we have to put c square lambda 2 by pi root over into e to the power integration of, again p dx is there, that means c square omega square dt, c square omega square dt into dx is there. So here dt we have to put dt. Okay, here we have to put dt plus c, right? Okay, clear? Okay, now put that implies. So that implies fc omega t into here c square omega square is the constant. So integration of dt will be t. So this will be e to the power c square omega square into t, right? Is equal to, here you can see c square lambda 2 by pi root over is constant taken outside, c square lambda into 2 by pi root over taken outside, integration of e to the power, this value will be how much, c square omega square into t, okay, into dt plus c. That implies fc omega t into e to the power c square omega square t is equal to c square lambda 2 by pi root over, these are constant written as such. So integration of this one is nothing but e to the power at dt. That means integration will be e to the power c square omega square t by the constant c square omega square plus another constant, suppose d plus c we written as a. Okay, so let this is your equation number, 3. Okay, here in your equation number 3, a is a constant. Okay, put it in a bracket, sorry, in a box. So a is a constant can be evaluated by using initial or boundary value condition. So here you can see another boundary value has been given, that ux0 equal to 0. Now we are going to consider first boundary condition to find out the constant a. Okay, now consider the initial first boundary condition. Okay, now consider initial condition I, that is your ux0 equal to 0 for x is greater than equal to 0, this one. Okay, now we are going to take the Fourier cosine transform both the side. Take Fourier cosine transform of the above equation. That implies Fourier cosine transform applied over left hand side, and here Fourier cosine transform of 0 will be 0. So that implies this will be written as what? This will be written as 1 by 2 pi root over 2 by pi root over, here for 2 by pi root over. Okay, 2 by pi root over. So 2 by pi whole root over ux0 into cos omega x into dx will be equal to, right hand side will be 0. So that implies this value is nothing but fc Fourier transform cosine transform applied over x. So it will be written as omega 0 will be equal to 0. So fc omega 0 we found that 0. Okay, let this is your equation number 4, right? Let this is your equation number 4. Now then consider equation number 3, this one, at t equal to 0. At t equal to 0 means this will be 0, e to the power 0 means 1, and here e to the power 0 means 1 and plus a. Okay, and here we can see c square can be cancelled out. We can write here itself. Okay, now consider equation number 3 at t equal to 0. So that implies we have to write fc this one omega 0 here e to the power 0 will be equal to 1 is equal to right hand side here c square got cancel. We found lambda by omega square. Here c square got cancel. Lambda by omega square into 2 by pi root over this value will be 1 because e to the power 0 will be 1 plus a. Okay, so we have to write lambda by omega square into e to the power 0. E to the power 0 is 1 plus a, right? Okay, so here from this expression we found that we can found that a equal to minus this much. Why? You just consider equation number 4. Okay, you just consider equation number 4. This value equal to how much? 0. So that implies 0 equal to lambda by omega square plus a using equation number 4. Okay, so if I'm going to use equation number 4, then instead of fc omega 0 we have to put 0. So that implies a value we found that here one thing I forgot to write here 2 by pi root over is there. 2 by pi root over is there. So here 2 by pi. Okay, 2 by pi root over. So here 2 by pi root over. Okay, so here a will be how much? Minus 2 by pi root over into lambda by omega square. So a value we found this much. Let this is your equation number 5. Now if I am going to put this value a value in equation number 3, then we can get the general solution of this differential equation. So now if we are going to put 5 in equation number 3, we get here you can see fc omega t e to the c square omega square t fc omega t e to the c square omega square t equal to c square. Here you can see c square got cancelled. We can get lambda by omega square into 2 by pi. So same thing you have to write is equal to lambda by omega square into lambda by omega square into 2 by pi root over into 2 by pi root over into e to the power c square omega square t e to the power c square omega square t plus a value we found this one. Okay, minus 2 by pi root over into lambda by omega square. Okay, so that implies we can get that implies what we can get. See, e to the power c square omega square t I am going to divide with all the term. So left hand side will be fc omega t equal to you have to write first 2 by pi root over into lambda by omega square into, if I am going to divide, both are will be cancelled out, then this is will be minus 2 by pi root over into lambda by omega square into e to the power. See, if I am going to divide this term with this one, if I am going to take to the numerator, it will be c square minus c square omega square t, right? So that implies this will be written as fc omega t. Here you can see this term taken common outside, 2 by pi root over 1 by lambda by omega square whole into 1 minus e to the power minus c square omega square t. Okay, now we have to apply inverse Fourier cosine transform on this equation number 6. So let this is your equation number 6. Now to get general solution of given question, apply inverse Fourier cosine transform on equation number 6. We get what we get here. You can apply inverse Fourier cosine transform. Left hand side we have to apply fc omega t is equal to inverse Fourier cosine transform applied on this one, that is your 2 by pi root over into lambda by omega square into 1 minus e to the minus c square omega square t, right? Okay, so here you can see that Fourier cosine transform of uxt, Fourier cosine transform of uxt is nothing but fc omega t. See this is nothing but Fourier cosine transform of uxt, that is your capital F omega t. So if I am going to apply for inverse Fourier cosine transform on this one, this is your fc omega t. Okay, this value is nothing but fc omega t. If I am going to apply inverse Fourier cosine transform over fc omega t, then I am going to get uxt. Okay, so this value inverse Fourier cosine transform, if I am going to apply over this one, then I can get small uxt will be equal to, here inverse Fourier transform if I am going to apply, then it will be 2 by pi root over 2 by pi root over into 0 to infinity this much value, 2 by pi root over into lambda by omega square into e to whole into 1 minus e to the power minus c square omega square t into cos omega x into d omega. Okay, see, whenever we are going to consider Fourier transform, here the Fourier transform applied over x, and we have to write dx, then corresponding Fourier inverse Fourier cosine transform will be omega x d omega. Okay, omega x into d omega. You just recall that suppose ft we have and we are going to apply Fourier cosine transform upon this. Fourier cosine transform has been applied. Fourier cosine transform applied over f small ft is nothing but 2 by pi root over 0 to infinity ft into cos omega t into dt, right? But and this is nothing but fc omega. Okay, so if I am going to apply inverse Fourier cosine transform over this one, inverse Fourier cosine transform on this one, it will be written as 2 by pi root over 0 to infinity fc omega into cos omega t into d omega. Here omega should be there, t should be there, and here you can see that this one when Fourier cosine transform we considered x is there, omega where omega is there means cos omega is there means for inverse Fourier cosine transform we have to write what, omega x into d omega. So that implies we found uxt will be equal to, here 2 by pi root over 2 by pi into lambda by omega square. See, omega square could not be taken outside because this is the integration with respect to omega. Omega will be inside the integration. So lambda 0 to infinity 1 minus e to the power minus c square omega square t by omega square into cos omega x into d omega. So this is our required solution of the given question, whatever we have been derived in detail. Okay, so for this question, the solution is this one. Okay, so write down the note whatever we have been discussed. You just check wherever you can, skip the steps in your exam, but I suggest write down all the steps in your note. Okay, so thank you so much for watching this video, and in our next class we are going to discuss another problem uh, based upon application of Fourier transform. Okay, so thank you so much for watching this video. Thank you.